So, good morning, good afternoon, good evening, everyone. My name is Marino Vigliotti. I'm the Senior Sales Engineer at Kerio, and today with me I have the pleasure of hosting my colleague.
I'm Martin Šimek. I work as a Senior Developer at Kerio Technologies, and I will show you some more technical parts of this presentation.
Fantastic. Thank you very much, Martin. We running today the first of the three dedicated webinar about security threats, about the security in the SMB, and the next one will be next week, and then on the week after that, same time, no changes. So let's start and let's have a look about the agenda for today. We will be focusing on unprotected devices. Very quickly, we'll go over why people hack IT systems. We will show you a router hacking. Martin will show you how a router can be hacked very easily from the inside. Then we will move on to understanding why industry-specific devices can be very vulnerable, and we'll look at the web camera hacking. This can be a hotel or anything else that is in that category. And then we will look at the solution of the Wi-Fi, how to protect the Wi-Fi devices. So, hacking. Well, the hacker is there, and what they are looking for. What they're looking for when they need to hack, they mainly look at two things. The first part is to go for the easiest one, which is default credential or weak credential. Default credential can be admin, admin password, or very weak credential, or possible misconfiguration. And Martin will show you how, by leaving default credential, can be leading to your router hacked from the inside. Next, if they don't succeed in that, they will look at the vulnerabilities in the system. Let's have a look at what actually means, and we will look in the second webinar when you have a weak system that it means there is a flaw in the software. This is what will not be covered today, will be covered next week. In more details also with the web camera hacking, how can be patched. From a company perspective, hacking can be classified in two different ways. So you have large companies and small companies. The large companies, the approach they have is very, very simple. They know they are at risk. They are cyber attacks ahead. The company, well, we are too small. You know what? We are not a target. There is no reputation at all. The large company, as you know, they need to dedicate vertical software, they need to dedicate teams exactly to protect themselves. And this leads to much more investment and requires keeping up to date with the threats. So the large company, pretty much, they try to keep pace with what's happening in the security world, with the hacking and everything else. The small company, they always think that the SMB security is too expensive. We don't have to do this. Let's crack on with what we can do as a business. But this leads to something different. So leaves for the SMB, and today we'll be purely talking about small companies, how the SMB can be vulnerable. So we will look at a company from the outside. So the device there on the outside, in this case, would be a DSL router or Wi-Fi access point. These are the devices touching the outside world and how they can be exposed to vulnerabilities. And then we will look at the inner circle. The inner circle is when you get into the network, you will have devices which don't have AV. They have embedded OS like Windows XP or Linux fully fledged, or even application like Adobe Connect or Adobe Flash or plugs in. Let's have a look at modem router. This is very important. You understand the difference between a modem and modem router hacking. So most companies they have they fall in two situations when they have a modem. The first one, They receive a modem, is managed by the ISP, and the ISP does everything. It means they manage the public IP address, they manage the NAT, they manage the patching, and in this situation, you as a customer have no control at all whatsoever. We will discourage, if it's possible, to fall in this category and take control of the router. If not possible because you have the contract with your ISP, well, maybe look at changing it. The second one is where we are more interested. You as a user, me at home, you as a professional in the office, or the reseller that managed the router can actually have three action on this. The first one, set up the modem in a router mode, which will allow dynamic or static IP address, will provide the credential PPP, OA, OE, and finally the bridge mode, which is the one that we want to encourage people. So if you are in the second categories, we will take you through on what is the most secure way of doing security on the outer part of your business. Modem in router mode. You may be familiar with some of these screenshots. When you set up a modem, we'll provide you with the guidance through step by step, and what you tend to do is put your credentials and you establish basically a point-to-point protocol from your router to the actual ISP. By doing this, as you can see on some of them, they all tick the box, provide an IP address, ask for an IP address. So it means your router, so your modem becomes router and will ask for an IP address. What actually means? It means your device at this point is available for everyone to be probed for default credential or misconfiguration. This guy from there can start with their tick box, say, let me try, I have an IP address, let me try a default password, let me try weak password, let me try open ports, remote access. It means your device now is fully visible and not protected on the internet. So you think you have your default credentials, you are protected from the outside. Let's have a look at a few screenshots. These are screenshots of most popular devices. As you can see, top left, no username, admin. In the second one on the right, username admin, password admin. Then you move username at the bottom and password admin, right? So you think you are okay. So let's have a look why you have a full sense of security. Martin.
Okay, let's have a deeper look on details at situation Marino just described. So from outside there is no port listening. Even though you have public IP address, you're technically invisible for the internet. But inside you'll have the default credentials, so they are known in advance to any attacker. So you think you have a fortified doors, security glass, electric alarm system, so no one can get physically into your network. So with this assumption, you think everything is protected from both sides, from one physically, from the other by turning off any ports. So what if you receive an email or a link, doesn't matter how you receive it, which downloads something from the internet and open it in your browser. Now the page is being interpreted by web browser at your computer, which is already in your local network. So it means something from the outside got inside and see the modem from the other side. If we take a closer look inside the page, it consists of two parts. First part is the content you came for. The second part is hidden from your eyes, and it's under with the JavaScript that tries default IP addresses, as you saw before on one of the slides, and send them requests according to in advance known credentials. So the request is held on behalf of your computer and is directed to the modem. Generally, not only modem is the target of attack. The JavaScript can scan whatever it finds in the network and try default credentials. So here you can see if attacker tried this combination, it's high probability for him to succeed. And now let's see a real life situation, what can happen if you have unprotected devices and outdated browsers.
This is a real live hacking that has been prepared for you by Martin.
So here I assume I'm a lazy administrator, and because of the sense of security I left the default IP address. Then I leave the default password because of the fortified door and security windows, and I just make sure that I didn't enable the remote management because I want to be invisible from the internet. Just to be sure, and for the next content of the video, let's take a look whether we have public IP address, and we need it for comparison later. So yeah, we have a public IP address, and that's good that I haven't enabled the remote management because I would expose myself to the internet, which is harmful. So now move to the next computer, which in this case it's some regular user's computer. And the user is using some weird browser, maybe outdated as well, and he obtained some link. For the purpose of demonstration we visit one site with a link. As I said, it doesn't matter how you obtain the link. This page is promising user to show him his public IP address, which is a part of our demonstration because we want to show that the server on the other side is aware of your public IP address. So the user clicks the link, which opens up the page, and the page does what it promised. It shows us our public IP address, which you can see is the one we saw in the modem. But something weird happened underneath, because now we move to the computer somewhere in the internet, possibly on the other side of our planet, and the attacker uses the public IP address, which was known from the page we opened, access the standard remote administration port. Here he set up new password he changed during the attack, and voila, he is logged into my modem. To prove it, you can see it's the same IP address as before. He can also see what's inside my local network, and based on the MAC address and the name he can guess brand and type of the device, which can be attacked further. So by forwarding some interesting port according to type of the device, like here in port forwarding menu, he can expose part of the chosen device to the internet and attack it from the comfort of his home. So for example, we can set it here, or if there is a device consisting of many ports, he can utilize the feature called DMZ, demilitarized zone, and send all the ports from the modem to the selected device, which completely exposes that device to the internet. It has two consequences. One, once the device is not protected by the simple firewall in my modem, and the second, it's exposed, so he can start attacking. Okay.
Fantastic. Thank you very much, Mark. I wanted to ask you a question. So does this person actually sits in somewhere on the other side of the world and does all what you've done, or because it takes a bit of time to doing this?
This demo was for the purpose of demonstration. In a real world, attackers have everything prepared in advance in the form of scripts and robots that crawls the internet and scanning random IP addresses for open ports and makes the report what it finds, or it can even start the attack straight away and just send attacker obtained credentials or obtained access to some device.
Fantastic. So the attacker is nothing else than a programmer doing programming by hacking rather than going looking for things.
Yeah.
So how do they do this?
Attacker is a very skilled programmer with a tremendous knowledge of security.
So can you show us how they do it?
Okay, so the weird what happened beneath can be shown on this real page that even fits in the slide of a presentation. There are three main parts of the code. First one is what we saw and what we came for. That's the part saying hello and showing your IP address. Just a snippet of code of PHP and HTML together, which is the visible part. Then there is a part of the page not being displayed. This means it doesn't occupy any space on the page. It causes no action. It's completely hidden. Then there is a third part which causes the main attack. That's the form targeted to the default address with the default credentials to some URL accepting changes of the modem. So it needs some parameters. The most important for the attacker is to enabling remote management, which is one part of the form, and this form is absolutely the same form as you saw in the real configuration interface of the modem. Then there is a piece of JavaScript that executes the form sending. It submits the form to the iframe, which is in between, and it's also in the hidden part of the page, and executing the form into the iframe, which is hidden, causes no visible changes to the page. It causes no redirection, so everything is invisible, unlike if you submit form that is visible and that take you to another page. So, and that's what happened to the user that used unknown browser when he visited the page.
Perfect. Thank you, Martin. Can we do something about it? I think we can. So the first step is to move on to changing the modem from a router just to a bridge mode. So I will briefly take you through what you're probably doing now if you don't use the bridge mode. So the bridge mode is different than Martin will show you. So if you're using in the router mode, we'll connect to the telco with the DSL connection, will provide the credential using the the point-to-point protocol, and request the IP address. By doing this, you're actually exposing again your router. So Martin, can you tell us how can we solve this problem?
Yeah, so as we saw in the demonstration, the modem inside our network not only acts as a modem but as a central part of entire network, and unfortunately it has all the features as a fully fledged computer. So our goal is to get rid of this unprotected computer and replace it with something smarter, which lets us to change the modem into bridge mode. The bridge mode is something like if you have a British socket and Italian plug and you need some adapter. The bridge mode just converts the layer 2 communication from DSL connection to the Ethernet wires. So modem in this mode just connects you to ISP's private network with only level 2 communication. So you need one more element in your network which will act as a center part of your network. In this case it's a firewall with DHCP capabilities, routing, firewalling and whatsoever. And it's task of the firewall to dial point-to-point connection, which brings you the layer 3, the IP layer, to your network. And it's dialed over the layer 2, which we have from the modem. Then you can set up the NAT and provision the rest of your network.
Fantastic. Thank you very much, Martin. So let's move on to the second stage of, and we are going inside the network now. We looked at the outside, so the inner devices. This is where the Internet of Things and network devices is spreading very quickly, and is very simple. We have it all around, and we show you what actually means. For an SMB, flat network is the default. It's easy to manage. Flat network means everything on the same segment. There is no need to introduce complexity. You maybe have another segment where you have your Wi-Fi, but that's it. This is what a flat network is every day, and what we want to show you now is actually the consequences when you go in different industries. So let's have a look at the Internet of Things. When you are at home, you have a router, fridge, and many devices. They are networked. In the business terms, it means you have IP level on a smart TV that is in your hall, presenting the latest company figures, specialist equipment, and so on. All these things, they have three things in common. They are designed for one thing, to perform a task, and it means they have very little resources left for self-defense. They don't have AV installed, they cannot run any terms of protection looking at webcam or smart TV. And at the same time, they are fully fledged computers. Fully fledged, it means these people developing a smart TV, they get a Linux-based, or maybe they have Windows XP, and they have everything enabled there. They just have OS embedded, which leads to the last and the most dangerous part of having Internet of Things attached. Rapid development. The people developing these great devices, they don't think about security. They can't. They always say, put it behind the firewall and that's it, you're safe. That's the attribute of this Internet of Things and network device. They assume that you are behind the firewall and you're safe. Let's have a look at some industry-specific risks. So, if you are in the manufacturing, you have a normal flat network, few devices here, receptionist, phones, and so on. But maybe you touch everything else on that flat network. You can have copiers, you can have a printing machine, you can have boards. They are all running embedded OSs, and they are all on the same segment as your computer, and they have again nothing of the things we showed you before, AV, personal firewall, nothing at all. You move into warehousing, gets even bigger. You have items attached to pallet, you have enough Wi-Fi to cover everything, and everything is super flat again. So you mix your normal internal network with everything else because your ERP system needs to talk to all the devices to be tracked, to the forklift and so on. Again, super flat network, mixing protected devices on your left with totally unprotected devices, Internet of Things on your right. Health, dentists, doctors, they don't need supercomputers or super networks. And they have all these X-ray devices. The dentist takes a nice X-ray in your mouth and gets displayed in the room. And again, this is a fully fledged computer that is attached on the same segment and gets updated from the internet, and the next is next to your computer. In a gym, you have plenty of smart TVs, fully fledged Linux machines, plenty of Wi-Fi, web cameras, security cameras, super flat network, Android-based devices. Let's have a look where we go to eat. We go to a restaurant, you maybe have a nice meal, and then when you go to pay, guess what you're paying with? You're paying with the EPOS. This EPOS is nothing else than a Windows embedded device with nothing at all installed, and it's just computing the transaction, and is in a super flat network attached again to the rest of the network. If you go into a hotel, you want to have a look at something before you get there, and there is a web camera that is broadcasting on the internet, and this web camera is only pushing data out, is not pushing data in or getting data in, and again is attached to the rest of your network. Can you see some of your industry around there? They are all have one thing in common: a flat network with the PC, laptops, working devices, offices, and the rest is actually attached to that network, whether you are in the manufacturing or you are in anything else. Now, over to you, Martin. Can you please speak up a bit, because some people said that your volume is a little bit lower. Can you tell us something about web streaming?
Okay, so suppose the situation, you have a hotel and you want to stream view out of your hotel together with your web pages. So you ask some web hosting to host a page for you. They created the page and they ask you for the video stream. So in this case you have public IP address, so you can take the webcam and forward some port to the webcam to the URL that consists the image you want to stream on your page. So in the end the page is combined with the URL or with the image at the URL of your camera, and you end up with the mixed content. So people go to the page, download one part from the web hosting and the second part from your camera that is in your internal network. This might impose some problems. Let's take a look on vulnerabilities these devices have.
Thank you. Here we go.
Okay, in this presentation I'm in the position of an attacker, and I am aware of a restaurant that have the streaming live on their page. So I go to the webcam, and first thing I spot here is they have a very strange system of embedding. They provide you with the ordinary user credentials so you can see the stream. So let's input those credentials inside the authentication dialog, which first shows us there is some strange port and the public IP address, very attractive for an attacker. So after putting credentials in, we can see this live stream from the camera. So our attraction is turned towards the public IP address, and with built-in web development feature that can be revealed F12 in Firefox or Chrome, we can take a closer look on the pictures and their source especially. So pressing F12 reveals what we call Firebug, and we can take a look what requests are issued by the browser. Yes, these are the images from webcam, and we can see the URL has really some public IP address, and the CGI bin reveals it uses some old technology. So I'm interested whether we can find what brand of camera is it, and it's even visible from the response of the camera. So let's take the URL and see what's behind that URL, because it's really interesting for me as an attacker, because otherwise it's just URL. Yeah, that's the image from the camera. So what if we delete the path portion of the URL and see whether there is some kind of administration? Wow, we see that the manufacturer is the same as in the response, and the administration looks weird. So maybe let's try an Internet Explorer, because the old camera is maybe optimized only for web, for the Internet Explorer. The same credentials as on the page. Not only credentials are necessary, sometimes the camera is accessible without those credentials, to be clear. Oh, we can see that the administration looks much better. So let's go to the settings. They are pretty small options, because it's just ordinary user, but even with those simple settings you can cause damage to the restaurant, because by changing something they can end up with a page without the video. So let's write down the manufacturer name into Google and see that there are several very serious vulnerabilities, like executing arbitrary code, bypassing authentication, or even stealing credentials from admin. So there are pretty few serious security holes, and if we scroll down a little, we might see there are even snippets of code, so we can start attacking that camera straight away. But there is more to be discovered in the network. So they forwarded port, so it's probable they have few more ports forwarded to something else. Let's try one port lower if we find something else.
Okay.
Okay,
Martin, we are already at the video. Okay, so yes, the video was a little bit slower for Martin. What we've been showing you is the hacking of actually the Mitroki router as well. So Martin, we went through the video, it was broadcasted. I just wanted to ask you again, do you have hackers going through this, so they write exploit kits before they actually deploy this on the internet?
As I said before, they have robots that crawling the internet and scanning ports one by one, so they hit every one of them. Here we are trying just manually. Another ports. So we can see. Oh.
So Martin, we are now in the presentation because your video was showing you the ended it, and now we're moving on to the hacking side. We've done the video with the web camera, and we would like to suggest a way of protecting yourself when you have devices. And the best way to do this is through segmentation. So Martin, can you tell us how you can protect a flat network when you have this situation?
So now that we know which devices are vulnerable and has no self-defense mechanism, we can easily spot them in our network. And our suggestion is to separate them into dedicated network segment, like you can see on this slide. We call them in this presentation device segment and the workstation segment. In the device segment, we put all those so-called headless devices because they don't have any displays, monitors or whatsoever, and they of course have no self-protection. And in the other segment, we usually put the workstations, servers, maybe network storage if it's some professional. And then we have to set up some traffic rules, and in that case it's good that we have two segments and the firewall between, because we are able to enforce all the traffic from one segment to another to go through the firewall. So first rule to be set up is that workstation can access those devices, because you have those devices to be used. So this rule is absolutely necessary. And this rule helps to implement situation for safe embedding of the camera, because you can download the image only internally from the camera to the computer and then present it on behalf of that computer to the internet. Or better, you can download it again with the computer and then push it to the web hosting service, so the image is presented on behalf of that hosting service, which is far more secure than presented from your personal computer. The next rule to be set up is that devices cannot establish connection on the opposite direction. So once the device gets compromised, it cannot start scanning your local network and trying default credentials or holding any other attacks to your production segment. However, on the other side, you have to allow those devices to establish connection to the internet. This direction is needed for devices that needs some authentication from the manufacturer because of the hardware keys, for example, or they have a cloud-based settings somewhere in the internet, so they call home to their cloud service. And finally, you shouldn't allow any communication from the internet to the device segment. Note the opposite direction. This direction means who is the first trying to establish the connection. So no one from the internet can establish connection to the camera, but the camera can establish connection somewhere to the internet. So this acts as a one-way tourniquet in a subway or train station or shopping or whatever.
Perfect.
So that's our suggestion how to make your devices more secure.
Thank you very much, Martin. And now we move on to the last stage of the security, and we'll be precisely speaking about Wi-Fi. So with the Wi-Fi, the most common deployments are where you use your router as a Wi-Fi device, and you attach your internal LAN with the IP address .3. Then you create an SSID for the corporate LAN, and is .1, and then you say you might as well use it for guests. By doing this, everything is wide open. Even if you have segmentation at IP level, you are absolutely totally wide open. This is also true if you have a firewall. If you have a segmentation between your the internal LAN and the two SSID. The two SSID, they can talk to each other because they are routed via the IP level, .1 and .2. So both situations, they do not provide the security that you need. So the security happen at in two different flavors. The first flavor is you have, and this is the easiest, you have two separate Wi-Fi devices, and each one will broadcast its own SSID, totally isolated, and you will see how. The next one, if you want to, and this requires some skills and some other equipment, you will have one single device. You will broadcast from that device two separate SSIDs, but you do need to use VLANs. And we will show you the diagram how. So, two devices, two SSID. If you have a router over there on your left which has Wi-Fi, please do disable it, because it's actually exposing you straight on the internet as you've seen before. Then you have a physical cable that goes from your guest SSID straight into the firewall. Then the corporate SSID will go on the other one. Okay, and this is the safest and the most secure one, because as you can see from screenshot from a typical firewall, in this case is Kerio Control, you have the internet on the top, then you have your local LAN, which is joining effectively the SSID corporate and internet LAN together, and they don't get routed to the SSID guest. They are physically separate, and this is the best way to do it. Physical. If you have a situation where the SSID from guest tend to go over, your separation of the two LANs, of the two Ethernets, they get blocked at the firewall level. Instead, if you have one device and you want to have two SSID, you have a situation where you need to have two separate IP range. You must be sure that the Wi-Fi device is not acting as a switch, router, or anything. Otherwise, it is able to route .1 and .2 between each other, and again, you are back to square one to not security at all. Then the second step is to have a single cable that goes in your LAN, Wi-Fi called over there, but you do need to have firewall rules which stop traffic between the two segments, and also stop the segment from guest going to the normal LAN. So makes the things a little bit more tricky, but it's still achievable. The ideal one, which is the most secure one as well, and is actually provides less headache for people, is to have the internal LAN. Again, you don't use your Wi-Fi on your router. Don't be tempted. It's not worth. Then you have a device which doesn't support only multiple SSID, but also support VLANs. So every time you create an SSID, you assign it to a specific VLAN. This VLAN gets packed onto the cable. They go together. They get isolated. They get to possibly a router managing VLANs. Most likely your firewall will be able to manage VLANs too. So how they will appear? They will appear in this way. to the router or ideally the firewall, they will appear as two separate cables. Effectively, you're carrying over one single Ethernet, but the VLAN virtualize your cable and will appear like having two separate Wi-Fi devices broadcasting two separate SSIDs, and will cause less of headaches in terms of routing. There is a security, and you can just put your guest interfaces to go out and not be routed to anything else. Summary of the solution. What we looked at today, there were three problems, and the first one we saw is to introduce a firewall. If you already have a firewall and you're running your router in router mode, sorry, your modem in router mode, switch it to bridge mode. It's very easy, very simple, and your firewall will provide you with the credentials to be dialed in point to point and go onto the public IP address from your firewall onwards, not from your modem. The second one, which Matt introduced, is a separation of devices which can have some sort of protection, whether it's firewall, personal firewall, AV. They have at least the protection that they can be self-defending themselves when something happens inside. The rest, you put them on a separate segment. Again, you have two flat networks. They can talk to each other. Martin has shown you what type of rules and traffic you need to have a firewall level. So you can still have a pretty simple segmentation of an SMB level company, and you are not adding overheads to your network. And finally, we see now, this is one of the 2 or 3 solutions you can have. You do not run SSIDs on the same Wi-Fi devices unless they've been tagged to a VLAN, or you increase the level of security by routing at the router level, which makes it a little bit more challenging for you. However, these 3 steps, they should be bringing your network onto a much more secure network, working from a small company point of view. What we will look at next week is the discover known hacks, and the week after we'll be talking about ransomware, identifying which version and possibility to decrypt it.